I am Dr. M. Laxmidevi, Associate Professor in the Department of CACDS at Institute of Aeronautical Engineering. Today's topic is multidimensional arrays in C. So in the previous video lectures, we have discussed about single dimensional arrays or one dimensional array, and there we have discussed in detail about the declaration, initialization, and the other concept is how to access each element of an array. So accessing elements of an array along with some small programs we have seen. So in this video lecture we learn about multidimensional array. So first let us discuss once again what is an array. So array is a collection of homogeneous data, and this data is stored in contiguous memory locations. So similar concept of arrays can be extended to multidimensional arrays. So here multidimensional arrays, instead of one dimension in single dimensional arrays, we have more than one dimension. So multidimensional array can be referred to as an array of array which stores homogeneous data in tabular form. So here we can see the syntax for this. So syntax for this multidimensional array is, so data type, then array name, and in square brackets we have size 1, size 2 and so on up to size n. So this number of size 1, if we have only one dimensional array, so we'll have only one size 1. So here data type is type of data to be stored in the array. Array name is the name of the array. So the rules for giving the name of the array is same as the variable name. So that we have discussed in the previous video lectures. Next to size 1, size 2 and so on up to size n. This is the size of each dimension of the array. Now here in this video lecture we will discuss in detail about two-dimensional arrays. So what is two-dimensional array? How to declare a two-dimensional array, and what are how to access a two-dimensional array elements. So two-dimensional array has two subscripts or indexes, you can say. The first subscript refers to the row and the second refers to the column. First we will see the declaration, how to declare a two-dimensional array. So in order to declare a two-dimensional array, this is the syntax. So here also we have the data type, then array name, and then we have two subscripts here. The first subscript refers to the rows and the second subscript refers to the columns. So this size 1 refers to the number of rows and size 2 refers to number of columns. So for example, if you declare a two-dimensional array in this way, int a of 3 and 3. So it declares a. So a is the array name, and this array will store elements of the type integer. So it declares a as an integer type with 3 rows and 3 columns. So first subscript is number of rows and second subscript is, or you can say first dimension and second dimension. So first dimension gives, so in two-dimensional array we have two dimensions. So first dimension gives the number of rows and the second dimension gives the number of columns. Then this is another example, float num of 20, 25. So here float is, so it declares num as a floating point array with 20 rows and 25 columns. So this array is also a two-dimensional array. It will store floating point numbers, and the size of rows is, number of rows are 20 and number of columns are 25. So we can visualize this two-dimensional array as a for example, consider this one, a of 3 and 3. So this is a matrix. It can be visualized as a matrix of 3 rows and 3 columns. So first, in order to access each element of the array, so we can access each element of the array by array name and then first subscript and second subscript. So in order to access each element of the array, we need two subscripts. First which refers to this is the row subscript and this one is the column subscript. So suppose we have a of 0, 0. So a of 0, 0 refers to the first element of the array, two-dimensional array. So its size is 3 by 3. So 3 by 3 refers to 3 rows, and so we have 3 rows and 3 columns. So in order to access the row elements, the subscript or the index starts from 0, and since there are 3 elements, so there are 3 elements in the rows, so subscript is 0, 1 and 2. And for the columns also, since we have number of columns are 3, so subscript is 0, 1 and So first element can be accessed by A of 0, 0. So in order to access the second element, so we have A of 0, 1 and so on, A of 0, 2. This refers to the third element. So in the first row, we have these, in order to access the elements of the first row, and this is column 0, this is column 1, and this one is column 2. So row 0, column 0, element is A of 0, 0. Row 0, column 1 is A of 0, 1. Row 0, column 2 is A of 0, 2. Similarly, row 1, column 0 element can be accessed by A of 1, 0. And row 1, column 1 element can be accessed by A of 1, 1. And row 1, column 2 element can be accessed by A of 1, 2. And the last row elements can be accessed by A of 2, 0. This is A of 2, 1. And this one is A of 2, 2. So in this way, we can visualize this as a matrix of A of 3, 3 can be considered as a matrix of 3 rows and 3 columns. And this is how we can access each element of the array. So we can consider this as a matrix of 3 rows and 3 columns. So actual memory representation of 2D array is in this way. So these are stored, the elements are stored contiguously. The elements are stored in contiguous memory locations. So first element is, suppose we have, so this is the name of the array. If you have taken x as name of the array, so first element is x of 0. After that, in the next memory location, the element stored is x of 0, 1. So all the row elements are stored. X of 0, 2 is, these are the elements of the first row. After that, the second row elements are stored. So these are the elements of the third row. The starting element address is nothing but the base address. Now initialization of 2D array. Now let us see how to initialize a 2D array. So here we have row size as 2 and column size is 3. So that means the number of elements in the 2-dimensional array are 6. So there are total 6 elements in the array, 2-dimensional array. So we can consider this as a 2-dimensional array can be considered as it has 2 single dimensional arrays. So each single dimensional array has 3 elements. So therefore we can write it as, so suppose these are the elements of the first single dimensional array and the elements of the second single dimensional array are, so we can consider this as 2 single dimensional array. Each single dimensional array has 3 elements. So these can be separated by parentheses or these braces you can say. So we have 4, 5 and 6. So these are the elements of the one single dimensional array and these are the elements of the another single dimensional array. So row elements, or you can say these are the elements in the first row and these are the elements corresponding to the second row. So there are 2 rows, so there are 2 sets of inner braces as you can see here. This method is advantageous. Why? Because it is easier to understand. Next, another way of initialization is directly you can, without using any of these braces, so directly you can write all the elements which are there. So for example, so 2 multiplied by 6, total 6 elements you have. So suppose 1, 2, 3. So these are the elements of the array. So up to 1, 2, 3, 4, 5 and 6. So these are the elements of the array. First 3 elements from the left. So first 3 elements from the left, they are in the first row and the next 3 elements in the second row. And these are the next elements in the second row and so on. Now let us see how much memory is occupied by these elements. So we know that integer data type occupies 4 bytes. So that depends upon the architecture of the machine also. So suppose it takes 4 bytes integer data type. So there are 6 elements here. So total memory occupied by this array will be 2 3s are 6. So 6 4s are 24. So this many memory locations will be occupied by this array. Now these are some valid declarations and invalid declarations. So for example, suppose here itself we declare and initialize the array. So this is a 2-dimensional array, row size is 2 and column size is 2. So total elements stored which can be stored in the array are 4. So 2 2s are 4. So suppose these are the elements, array is initialized by these elements, these are of integer data type 1, 2, 3 and 4. So this is valid declaration. Next, another way of valid, this is also valid declaration. So here we have specified the column size. So column size means, so in each column, So there are two columns. So these refer to the first row and these refer to the second row. So in each column we have two elements. Now these are some invalid declarations. So where you are not specifying any of the subscripts, so these are invalid declaration. So here second dimension is not specified. So this is also invalid declaration. Why? Because the second dimension is not specified. We don't know exactly how many elements are there in the columns. Next is initialization of 3D array. So 3D means three-dimensional array here. So three-dimensional array. So in the next slide, we will discuss about how, till now we have seen static initialization of 2D array. So in the next slide, we will discuss about runtime initialization of two-dimensional array. So three-dimensional array means, so here we have, so suppose this is the name of the array. So we have three dimensions here. So suppose this is the first this dimension is referred to as block size. This dimension specifies the number of rows, and this dimension refers to the number of columns. So here we have block size, row size and column size we have. So suppose for example, this is initialization of three-dimensional array. Suppose we have an array. Syntax for declaring three-dimensional array is also same, but here the number of subscripts will increase here. So int a of declaration syntax is data type, then array name, then this is the block size, this is the row size, and this one is the column size. So here this refers to block size, this refers to row size, and this refers to column size. So we can consider three-dimensional array as a group. For example, consider this syntax. So int a of 2, 2 and 3. So this is the block size, this one is the row size, and this one is the column size. So here we can say that, so there are two two-dimensional arrays, and each two-dimensional array size is 2 by 3. So row size is 3 and row size is 2 and column size is 3. So this is how we can initialize the elements in the three-dimensional array. So these are the elements of the, so total elements in this three-dimensional array are 2 2s are 4, 4 3s are 12. So total elements, so 12 elements are there. Memory occupied by this array is 12 into 4. So this is the memory occupied by this array. So we can see here, so these are two ways in which we can initialize the three-dimensional array. So there are total 12 elements. So these elements are from, so directly you can write inside the braces all the elements separated by comma. So this is one way of initialization. Another way of initialization is where you can segregate the rows and columns. So there are two blocks you can say. So first block, so this is two blocks, you have two blocks of two-dimensional array we have. So each two-dimensional array size is 2 by 3. So block 1 and block 2 we have. So this is a two-dimensional array. So 2 by 3 we can consider. So first block we have 1, 2, 3, 4, 5, 6. Second block we have 7, 8, 9, 10, 11 and 12. So these are the elements of the first block and these are the elements of the second block. So these are separated by comma as you can see here. So this is how we can initialize a three-dimensional array. Now runtime initialization of two-dimensional array or any multi-dimensional array. So for two-dimensional array we have two blocks. We have two for loops you can see here. Initialization of two-dimensional array can be done by using two for loops. So by using nested for loops, we can initialize 2D array runtime initial. This is called as runtime initialization. So previously we have seen static initialization. So for runtime initialization we need, so this is the part of the code which initializes, which reads the values or which reads the data into the array. So for example, consider this program. So this we know this is a header file, this is a main function and this is the declaration part. The first sentence first statement is declaration part. So in the declaration part, we have declared two variables, I, J, then row, column, and this is the array. The array size is mentioned. Since it is a two-dimensional array, we have two dimensions. First dimension is 10 and row size is 10 and the column size is 10. So the maximum elements which can be stored in this array is 10 into 10, so which is equal to 100. So maximum elements which can be read into the array is 100. Now enter the size of the array, or you can say that, so here we need to, so all the, this depends upon the user. So, for user defined rows and columns, so this scanf function we have written. So this scanf function will read the number of rows and columns. So next statement, so in order to read the actual elements of the array, so we use two for loops. So one for loop will iterate over the rows and another for loop which will iterate over the columns. So suppose we are entering the row size as 2 and the column sizes or number of columns as 3. So 2 rows and 3 columns you have. So we can consider it as a 2 by 3 matrix. So each matrix, so this is a 2 by 3 matrix. So where you have 2 rows and 3 columns. So each row, first row element can be accessed by, so this is the 0th row and these are the columns 0, 1, 2. So this is 0 and 1. Row 0, row 1, this is column 0, column 1 and column 2. So this, so outer for loop will iterate over the rows, number of rows, and inner for loop will iterate over the columns. So the variable to iterate over, the variable which iterates over the number of rows are I, and the variable which iterates over the number of columns are J. So I will vary from 0 to 1, 0 to 1. So therefore, for this condition I less than 0, so this loop will run for, suppose we are taking 2 by 3 as a 2 rows and 3 columns. So this loop will repeat, outer loop will repeat 2 times and inner loop will repeat 3 times. So for j is equal to 0, so it will run for j is equal to 0, j is equal to 1 and j is equal to 2. So we have seen how this for loop working of nested for loops. In the previous video lectures, you can go through that nested for loops. So we use for loop. We have also seen the difference between for loop and while loop. So when we actually know how many number of times the loop is to be repeated, so there we use for loops. So when we don't know actually how many times the loop is to be repeated, so there we use while loops. So here we know how many times the loop is to be repeated, so therefore we use nested for loop here. So I will vary. So I is the variable which iterates over the rows and j is the variable which iterates over the columns. So by using scanf function, so here in order to read the elements into the array, that is two-dimensional array, so we need two subscripts. So one subscript refers to the row and another subscript refers to the column. Next, in order to print the elements of the array, so again we need nested for loop. So this nested for loop, so this is a variable which iterates over the rows and this is a variable which iterates over the columns. So I is equal to 0. So outer loop will run for 2 times, I is equal to 0, I is equal to 1, and inner loop will run 3 times, j is equal to 0, j is equal to 1 and j is equal to 2. Similarly, in order to print, so in order to access each element of the array, we need two subscripts, so I and j. So I is a variable which iterates over the rows and j is a variable which iterates over the columns, and %d is the format specifier. So correspondingly this value will be printed. Next, let us see program to print lower triangle of a square matrix. Now square matrix, we know that. So generally these two-dimensional arrays, in two-dimensional arrays we can use these two-dimensional arrays for operating on matrices, for performing operations on matrices. So for performing operations on matrices, we can use these two-dimensional arrays. So in this, mostly we will see some of the matrix related operations like matrix addition, then transpose of a matrix, how to find transpose of a matrix, and then at the last we will also see one simple program to find matrix multiplication. So here this is a program to print lower triangle of a square matrix in C. So we know that square matrix has rows and columns are equal. So 2 by 2 is a square matrix, 3 by 3 is a square matrix. Suppose what is this program about? So program to print lower triangle of a square matrix. Suppose we have a 3 by 3 matrix. So this is a 3 by 3 matrix. The elements of this are 1, 2, 3, 4, 5, 6. So 3 by 3 matrix will have 9 elements, 7, 8 and 9. So the output of this should be, if this is the input, output of this should be 1, 4, 5. This is 0, 0, 0, 7, 8 and 9. So this is the output. So this should be the output of this program. So this is what this statement means, program to print lower triangle of a square matrix. So this forms the lower triangle of this matrix and remaining elements should be 0. Now let us see how to write a program for this. Now suppose we have, so here we declare a two-dimensional, at the declaration here itself we have initialized the two-dimensional matrix also. So name of the array is matrix and row refers to the row size and COL refers to the column size. So here we can see that, so we have defined the row size and column size by using this hash defined directive. So this is called as preprocessor directive, or you can say that this is a macro, you can say. So whatever line states, it starts with hash defined. So that is a macro. By using macros, we can define the size of this array. Row size is defined as 3 and column size is defined as 3. So 3 by 3. So 3 into 3, maximum elements which can be stored are 9. So suppose these are the elements. So these are the elements of the first. So if this is the, so in this example we have taken the elements 2, 3 and 4. So these are the elements of the first row and elements of the second row are 5, 6, 7. Elements of the third row, these are 8, 9 and 10. So these are the elements which have been initialized. So this is the matrix elements. So again we have declared two variables I and j to loop over the, or to iterate over the rows and columns. So here, so with this for loop, so this is the code which is written. So this is the code which is written to get the output. So that is lower triangle of a square matrix. Now let us understand this code. So for I is equal to 0 and for I is equal to 0, the loop will run 3 times. So for I is equal to 0, j is equal to 0. Then j is less than 3. 0 is less than 3. This condition is true. So therefore, it will check this condition. So if I is greater than or equal to j. So I is equal to j. So I is equal to 0, j is equal to 0. This condition is true. So I greater than or equal to j. This condition is true. So therefore, the corresponding element will be printed. So corresponding element is 3. So at this position 3 will be printed. Next else, so it will not go to the else part. So it will come out. Then again j will be incremented by 1. Now j is equal to 1. So for I is equal to 0, j is equal to 1 now. Now again it will check this condition. So 0 is greater than or equal to 1. So 0 is greater than 1. So this condition becomes false. So it becomes false. So if it is false, then it will go to the else part. 0 will be printed. So corresponding element, that is 0, 1. So 0, 1 means 0th row and first column. So this element will become 0. Then again it will, j variable will be incremented. Now j is equal to 2 here. For say my value 0. Next to 2, it will check this condition. 2 is greater than or equal to, 0 is greater than or equal to 2. So this condition is false. So 0 is greater than 2. This condition is false. So therefore here also it will go to the else part and this line will be printed. So here this 0 will be printed. Next after this, j value will be incremented by 1. So j is equal to 3 now. So 3 less than 3, this condition becomes false. Now it will go to the outer for loop. So outer for loop, I value will be incremented by 1. So now I is equal to 1. So in this way, for it will check each element. So if the corresponding, it will compare this condition. If I is greater than or equal to j, if this condition is satisfied, if this condition is true, the corresponding matrix elements will be printed. So corresponding matrix elements will be printed as it is. So else 0 will be printed. So this condition is true for 0, 1, 2. These are the column elements. So this is the row subscript and this one is the column subscript. 0, 1, 2. So this condition is true for these elements. So this will be the output 2, 5, 6. Here it is false. Why? Because 1 is greater than or equal to 2. This condition becomes false. So here all the elements will be printed 8, 9 and 10. So in this way we'll get the output as this one. So 2, 0, 0, 5, 6, 0, 8, 9, 10. So this will be the output. So this is a program to print lower triangle of a square matrix in C. Now this is a program to read a matrix and print its diagonal elements. So we know that diagonal elements, suppose we consider same 3 by 3 matrix, if you consider 2, 3, 4, 5, 6, 7, 8, 9, 10. So in order to print only the diagonal elements, so this is a 3 by 3 matrix. Diagonal elements are 2, 6 and 10. So these are the elements to be printed. So we should get the output as, so for this matrix, if we enter a 2 by 2 matrix, only the diagonal elements must be printed. So this is a matrix or this is the array. The name of the array is matrix. The row size is 10 and the column size is 10. So maximum elements which can be read into the array are 10 into 10, that is 100. So here we are, by using scanf statement, we are reading the row size, number of rows, and by using here another scanf statement, we are reading the number of columns. Now here enter the matrix elements. So in order to enter the elements, matrix elements, we are using nested for loop. So one loop, one variable, nested for loop, we are using the outer for loop to iterate over the rows and the inner for loop to iterate over the columns, along with the scanf function. Inside this we have the scanf function. Then next, in order to print its diagonal elements, the condition to check whether the corresponding element is a diagonal element or not, we need to check the condition. So the condition is row subscript, row element is accessed by, so each element is accessed by two subscripts, row subscript and column subscript. So first element is A of 0, 0 or matrix, you can say, this is the matrix name. So matrix of 0, 0, this is the first element. So this element must be printed as it is. So we need to access only, so this is the condition to be checked. So for I is equal to j, if I is equal to j, then that element is to be printed. If rows is equal to column, so condition, this is the condition to check to print the diagonals. It must be a square matrix. In order to print the diagonal elements, the corresponding matrix must be a square matrix. So for that condition, we are checking this. For that, we are checking this condition, rows and columns. So R is equal to C. If R is equal to C, so R is used to refer to the rows and C is a variable which is used to refer the columns. If R is equal to C, then we have to print the diagonal elements. Otherwise, matrix is not a square matrix. It is not possible to print the diagonals. So that is what, so if else part we are writing. In the if part, we have to print the diagonal elements. So in order to access each element, so we need to use nested for loop along with the condition. And the condition specified to print the diagonal elements are, so row and column, these elements are accessed by the variable I and j. So I variable iterates over the rows and j variable iterates over the columns. If I is equal to j, the corresponding element has to be printed. Else, so in the else part we have written /t, /t. So /t refers to tab. So it will set a tab. If this condition is not satisfied, so this tab will be set. Next, after this printer, after the inner for loop, so this is the inner for loop and this is the outer for loop. After the execution of this inner for loop for the number of, for this many times, so that is 3 times. So suppose after these many times, then cursor will move to the next line Then again this outer for loop will be executed for the number of rows which are specified. Suppose the input given is 2 by 2. So 2 rows and 2 columns we have entered, and these are the matrix elements 1, 2, 3 and 4. So output of this program is, so this is a program. First diagonal element 1, 2, 3 and 4. So diagonal elements are 1 and 4. So 1 and 4 are printed. So 2 and 3 are not diagonal elements, so they are not printed. Next is program to print transpose of a matrix. So transpose, we know that in order to take matrix transpose, suppose we have 1, 2, 3, 4, 5 and 6. So transpose of this matrix is number of the rows and columns will be interchanged. Row elements and column elements will be interchanged. So transpose of this matrix is 1, 4, 2, 5 and 3, 6. So this is a 2 by 3 matrix. So it will be 3 by 2. Now let us see how to write a program for this. So this part of the code will remain same for all 2-dimensional arrays. So first is declaration part, where you declare an array ARR with maximum size, with row size 10 and column size 10. So these are the variables which are used to iterate or which are used to loop over the row and column, and M and N refers to number of rows and number of columns. Then after that, so we are actually printing the elements of the matrix with the help of this for loop. So this for loop, this nested for loop, this part of the program, it reads the array elements. This part of the program is used to print the array elements. Then program, and this part of the code is to print transpose of the matrix or the array, you can say. So this is row 0, row 1, this is column 0, this is column 1 and this one is column 2. So 0, 1, 2. Next, in order to print the transpose of this matrix, so this is the code we have written. So j is equal to 0, or j is equal to 0, j less than n. Suppose n is equal to 3, so m is 2 here and n is equal to 3. So these are the values given by the user. Rows are 2 and columns are 3. So here j less than n and then j plus plus. So this is the outer for loop, and inside inner for loop we are taking the variable I is equal to 0, I is equal to 0, I less than m. So this specifies the number of rows here, then I plus plus. So directly we are printing this printf statement will print the array elements. So ARR of ij will be printed. ARR of ij means, so first I is equal to 0. So 0, 0 will be printed. Next I is equal to 1. So this is 1. This is I less than m. So m is equal to, this loop will iterate 2 times. So I is equal to 0. This inner loop will iterate 2 times. I is equal to 0, I is equal to 1. This outer loop will iterate 3 times because n is equal to 3. So j is equal to 0, j is equal to 1 and j is equal to 2. So first element printed will be, so for j is equal to 0. So first element printed will be 0, 0. Next, after that, second element printed will be, so I is equal to, so j is equal to 0, I is equal to 1. So j is equal to 0 is, so this is the element will be printed. So 1, 0. So at 1, 0 we have 4. So therefore this is the output. So similarly, next again I value will be incremented by 1. So I is less than m. So this condition becomes false. So therefore it will go to the outer for loop. Now j value is 1. J value is incremented by 1. J is equal to 1. So this condition is true. Next it will print again this inner for loop will repeat 2 times. So these elements will be printed 2 and 5, 3 and 6. So in this way, this is a program to print transpose of a matrix. Next, program to add matrices using multidimensional arrays. Now let us see how to add two matrices. So this is a program to add two matrices. For that we need to declare two matrices. So these are the two matrices A and B, or two arrays you can say. So we have declared two arrays A and B. These are two dimensional arrays, and we need to declare another array also named as sum. So where you actually need to get the sum. So again we need two variables I and j to iterate over the rows and columns. So R and C refers to the rows and number of rows and number of columns. So this part of the code is same. So this part is same. So this will read the elements of the array. By using the scanf function, we can read the elements of the array. So this part of the code. This is array A, and this will read the elements in array B, another matrix, another array. Now, program to add matrices. We know that in order to add two matrices, so both of them must be of the same dimension. If this is 3 by 3, another matrix also should be 3 by 3. So that code you can write. So if this is A and this is B, so you need to check the dimension of each matrix. If the corresponding dimension of this one and this one should be same, only then you can add two matrices. So that next program to add two matrices. So this is a code which is written to add two matrices. So in order to add two matrices, directly you can access for this also we need nested for loop. So nested for loop, two for loops are required. So in one for loop, I is equal to 0, I less than R, I plus plus. So this will iterate over the number of rows, and then again the inner for loop, j is equal to 0, j less than c, j plus plus. So you can also write I plus plus or plus plus I. Then inside this, so we have declared a variable sum, another matrix or another array we have declared sum of ij. So this is equal to, suppose we have array elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Suppose we have a 3 by 3 matrix. This is also a 3 by 3 matrix. So this is array A, and this one is array B. So we need to get the sum into the third array. The array name is sum. So output should be 1 plus 10, that is 11. So 2 plus 11 is 13, and so on. So in this way we can add two matrices. So directly access each element and then add them. So by using nested for loop only. So this is the code to add two matrices. Next, after that we are actually printing the matrices. So for I is equal to 0. So this is the code to print the array. This is the code to print the array where you have addition of two matrices. The array name is sum. So therefore sum of I and j. So in this way you can add two matrices using multidimensional arrays. So this is the test case you can see. So here we have entered two rows and two columns. So in the first matrix we have 1, 2, 1, 2. And in the second matrix also we have entered 1, 2, 1, 2. So output of this will be, sum of two matrices will be, so 1 plus 1, 2, 4, 2, 4. So this is the output. Next, this is another test case where we have entered two rows and three columns. So in two rows and three columns, so 1, 1, all the elements we have entered as 1. So two rows and three columns means 2 3s are 6. 6 elements will be there in each matrix. So 1, 1, 1, 1, 1, 1. So output will be, so 1 plus 1 is 2, 2, 2. So this is array A, this is array B, and this one is array sum. So this will be the output. Next, program to multiply matrices using multidimensional arrays. So here also we'll take two-dimensional array and write the program to multiply to and we'll write a program to multiply we'll write a program here to multiply matrices using multidimensional arrays. So here we have declared two arrays A and B, and also we have declared one more array where we need to store the multiplication, that is array C, then three variables I, J, K, M, N, P and Q. These are the integer variables. So this will read the column size and row size, and this scanf statement will read the column size and row size and column size of matrix 2. So we have two matrices, matrix 1 and matrix 2. So this will read the rows and columns of matrix 1. This will read the rows and columns of matrix 2. So this part of the code will read the elements into this array A, and this part of the code will read the elements into the array B. Now let us see how to multiply two matrices or two arrays, you can see. So this is the condition to satisfied. So this condition has to be checked. If this condition becomes false, then matrix multiplication is not possible. So suppose you have two matrices, one is 2 by 3 and another one is 3 by 2. Then matrix multiplication is possible here. Why? Because suppose this is M, N, P and Q. So if N is equal to P, then matrix multiplication is possible. Multiplication is possible. If N and P are not equal, if N is not equal to P, then matrix multiplication is not possible. So we will see the test cases, both the test cases we will see. So first is, if N is equal to, this condition you need to check. So first, printf matrix multiplication. So in order to multiply the matrices, we have used for nested for loops here. So one for loop to iterate over the rows, another for loop to iterate over the columns. Now let us see how this program actually executes. So first we have I is equal to 0. This condition is satisfied. Suppose we have 2 by 3, 3 by 2 matrix. So this is first matrix and this one is the second matrix dimension. So here N is equal to P. So this condition is satisfied. Now I is equal to 0. Then I less than M. This is M, N, P and Q. I is less than 2. That is 1 is less than. So here 0 is less than 2. So that is condition is true. So therefore it will enter the inner for loop. So this for loop J is equal to 0. So here J is equal to 0. 0 is less than Q. So Q is 2. This condition is true. So this is true. Here 0 is less than 2. This is also true. So therefore it will enter this inner for loop. So here inner for loop K is equal to 0. So 0 is less than N. So N is equal to 3 here. So this condition is true. So therefore it will enter this line or this statement will be executed. So we have declared third array. So we have declared an array C. Its dimension is 10 by 10. So C of ij, that means so I is equal to 0, j is equal to 0. C of 0, 0 will be equal to, so initial value of C of 0, 0 is 0. So 0 plus A of I and K. So these two elements will be printed. So A of I is 0. A of K is 0. This is multiplied by B of 0 and 0. J is equal to 0. So A of 0, 0, B of 0, 0. Suppose we have a matrix A. So its dimension is 2 by 3. That means 2 rows and 3 columns we have. So 2 rows and 3 columns, 1, 1 and 1. So another matrix B you have. So this is matrix B. So its dimension is 3 by 2. So 3 by 2 means 3 rows and 2 columns, 1, 1, 1, 1, 1 and 1. So matrix multiplication can be done by this way. So this and this will be multiplied. Matrix. So first element of the array, this array will be, so 1 into 1 plus 1 into 1 plus 1 into 1. So that is equal to 1 plus 1 plus 1, 3. Now similarly, this, so first row, second column, first row, first column element is 3. First row, second column will be, this is how you can do. So 1 into 1 plus 1 into 1 plus 1 into 1. So that is equal to 3. Next, second row and this one. So this one. So this should be the output. Matrix multiplication, this is the output. Now let us see how we can get the output, corresponding output. So in order to access the row, for the row subscript we have. So in order to iterate over the rows, so we take the variable I. So row 0 and this one is k. So this variable is k. This will vary from 0, 1, 2. This is also a kth variable. This is equal to j. So for initially it is 0, then after that it is 1. So this is I is equal to 0. So it will vary from I is equal to 0, I is equal to 1. Now you can understand with the help of this. So initially C of 0, 0 will be equal to A of 0, 0, A of 0, 0 into B of 0, 0. These two will be multiplied. That will be plus C of ij. C of ij is 0. So therefore C of 0, 0 is equal to 0. Now next k will be incremented by 1. Now k is equal to 1. So when k is equal to 1, this condition is checked. 1 is less than 3. So this is true. When this is true, C of ij. C of ij is 0, 0 only. So C of 0, 0, initial value we got it as 1. So 1 plus A of 0, now k is equal to 1. So 0, 1 into V of 1, 0. So A of 0, 1 is A of 0. A of 0, 1 is 1. Then B of 1, 0 is B of 1, 0 is this one. So 1 plus 1. So that will be assigned to C of 0, 0. Now C of 0, 0 is equal to 2 now. Now again k value will be incremented by 1. Now k is equal to 2. K is equal to 2. So 2 is less than 3. So this condition is true. So again C of 0, 0 is equal to, so initial, this value is equal to 2 now. Now this is A of 0, 0. I is same. K is iterating. So this is k is equal to 2. B of, now k value is 2 and this one is 0. So A of 0, 2, A of 0, 2 and B of 2, 0 is equal to 1. So 1 plus 1 into 1, these two are multiplied. 1 into 1 is 1, 1 plus 2 is 3. So C of 0, 0 is equal to 3. So in this way we got this element. This is equal to 3. Now again it will, k value will be incremented by 1. Now k is equal to 4. 4 is less than n. So n value is, 4 is less than 3. So that becomes false. So when this condition becomes false, it will come out of this loop. So C of ij will be printed. Then again it will go to this for loop. Now j value will be incremented by 1. So j is equal to 1 now. J is less than q. So j is less than q. Now this for loop, this loop will iterate 2 times. So this loop will iterate 2 times. So 0 is less than q. So that is true. Now again C of ij is initialized to 0. Now k of 0 is equal to, k is 0. Again this loop will repeat 3 times. So 0. Now again in the next element, next 0, C of 0, 0. So first element is C of 0, 0. This element is C of 0, 1. So this element will get. So code to I. So in order to access this corresponding element is obtained by 1 into 1 plus 1 into 1 plus 1 into 1. So that is equal to 3. So in this way you can go through this program. This is a simple program to multiply two matrices using multidimensional arrays. So these are the two test cases we have seen. So first, if you enter the row as 2, row size is 2 and column size is 2, 3, and another matrix 2. So row is 2 and 3. So suppose we have two matrices 2 by 3 and 2 by 3. So for this is M, N, P, and Q. So this is not compatible. For this matrix multiplication is not possible. So therefore we'll get the output as matrix multiplication is not possible. Next again, if you enter the row and column for matrix 1 and matrix 2. So first matrix dimension is 2 by 3, second matrix dimension is 3 by 2. So this matrix multiplication is possible. So matrix multiplication is possible and we'll get the corresponding output. So this is the output. So output of this is 3, 3, 3 and 3. So for these elements into the array. So in this way, we have seen multidimensional arrays, how to initialize. So in multidimensional arrays, mainly we have discussed about two-dimensional array, how to initialize two-dimensional array and how to access each element of the array in each element. Then after that, we have seen some programs where we have seen multiplication of two matrices or two arrays, multiplication of, then addition of two arrays, etc. So in this way, with this I would like to conclude. In the next video lecture, we'll discuss some more topics about C language. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.